So now we'll be discussing about another important concept associated with solving of linear inequations in one variable, which is the concept of replacement set and solution set. Okay, so I have not discussed about the set theory in any of my videos, so I will be discussing that. So for now, you just understand that in mathematics, a set is a collection of well-defined distinct objects. Okay, so for example, let's say we have a set of, let's say, whole numbers. Okay, the whole numbers starting from 0, 1, 2, 3, 4, 5, 6, like that. Or we can have a set of natural numbers 1, 2, 3, 4, 5, 6, and just like that it goes on and on. Then we have a set of integers, which is -3, -2, -1, 0, 1, 2, 3, like that. Okay, minus from infinity minus infinity to 0, then from 0 to 1 to 3 up to plus infinity, like that. So then we have set of rational numbers, irrational numbers. Then we can have set of, let's say, positive integers, negative integers. We can have set of alphabets also. We can have set of consonants, set of vowels, like that. We can have anything. Okay, so a set is a collection of well-defined and distinct objects which form a group. Okay, forming a group. So I'll be discussing about set theory in detail. So this is just a basic introduction. So now, what is replacement set? So our basic objective in linear inequation is to get a value of the variable x, whether it is x lesser than equal to, greater than equal to, lesser than, or greater than, lesser than, whatever it is, some constant value. Okay, we get a relationship between the variable and the constant. So replacement set is the set from which the value of x is to be chosen. Okay, it is the choice from which the value of the variable x is to be chosen, which satisfies the relationship of the inequation. Okay, solution set is the set of values which satisfy this relationship. This, whatever this relationship is, it should satisfy that. Okay, for example, let's say we got the final relationship between the variable as this. Let's say x lesser than 3. This is the solution, the final solution which we got. It is in the form of a relationship. Now let's say it is mentioned in the question that the replacement set is the set of natural numbers. Okay, the set of natural numbers. So the solution set will be, okay, the natural numbers set, that is equal to 1, 2, 3, 4, like that. So in this case, the solution set is we have to pick the values from this set of natural numbers which satisfy this relationship. So in this case, the solution set will be 1, 2. Suppose the replacement set would have been x belongs to, let's say, the whole numbers. Okay, so in that case, the solution set would have been 0, 1, 2, because whole numbers is simply we add a 0, 1, 2, 3, like that, it goes on and on. So it is 0, 1, 2, which is the solution set. So when the replacement set became the set of whole numbers, our solution set changed. Similarly, for the same relationship x lesser than 3, let's say we have the replacement set as x belonging to the set of integers. So in that case, the solution set would be all the negative numbers -2, -1, 0, 1, 2. Okay, this is the solution set. So when the replacement set changes, accordingly the solution set, the values which satisfy this given inequation relationship, that also changes. Okay, so this is just an example. In this case, this is the relationship which we have obtained by solving the inequation. This, whatever it is, it will be mentioned in the question that x belonging to the set of natural numbers, x belonging to this, x belonging to that whole number. So whatever it is, it will be called as the replacement set. Okay, the replacement set. RS, you can use it as short form. Okay, this is the replacement set, and accordingly, as the replacement set changes, the values which satisfy this relationship, that and the number of values in the solution set, that also changes. Okay, as you can see here, for different replacement set, the solution set is different. Okay, so this is the concept of replacement set and solution set. So the next concept which we are going to discuss related to linear inequations is plotting the solution on the number line. Okay, so we'll be discussing it with the help of examples. So let's say we have obtained a relationship as something like this: x lesser than or equal to 5. Okay, this is the relationship which we have obtained, and the replacement set which is given, it is x belonging to the set of, let's say, natural numbers. Okay, to the set of natural numbers. This is the replacement set. So the solution set will be 1, 2, 3, 4 and 5. 5 will also be included because it is x is lesser than or equal to 5. Natural numbers 1, 2, 3, 4, 5, 6, it goes on and on and on like this. So from this replacement set, we have obtained the solution set this, which satisfies this relationship, x lesser than or equal to 5. Okay, so if we have to plot this on the number line, it will be something like this. So 1, 2, 3, 4, 5, 6. So we'll highlight all these points with a filled in solid darkened circle. 1, 2, 3, 4, 5. Okay, so suppose instead of natural numbers, it would have been given x belongs to the set of whole numbers. Okay, x belongs to the set of whole numbers. So in that case, the solution set would have been 0, 1, 2, 3, 4, 5. Okay, so here if we just extend this whole thing, okay, it's 0 here, so this would have been the plotting of the solution on the number line. Similarly, if it would have been given x belongs to the set of integers, solution set would have been, okay, all the negative numbers, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, so in that case, the plotting of the solution would have been something like this. Okay, so let's say here it is 0, 1, 2, 3, 4, 5, 6, and it goes like that, and here it is -1, -2, -3, -4, like this. So here would have done it like this. All the negative numbers would have placed an arrowhead like this because it goes like this. All the negative numbers, then 0, 1, 2, 3, 4, and 5. Okay, it goes to the left hand side like this. Okay, similarly, if x would have been belonging to the set of real numbers, okay, real numbers, so in that case what would have happened is we have plotted the solution like this. Okay, here it is 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, like this. So let me copy this because there are 2 points which I will try to make here. Okay, one is for x lesser than or equal to 5 and other is for x lesser than 5. In case of real numbers, it is only applicable in case of real numbers. So let me copy this number line to save time. Okay, so we have two cases. Okay, the point I'm trying to make here is, let's say the same solution exists, the relationship which is x lesser than or equal to 5. So in this relationship 5 is included in the solution. In case of all the previous things, integers, whole numbers, and all that, these are distinct points, here 0 is applicable, -1 is applicable, but all the points which are in between 0 and -1, they are not applicable. Similarly, here 1 is applicable, 2 is applicable, but all the infinite number of points which are in between 1 and 2, they are not applicable as solutions. But here, in case of real numbers, all the infinite number of points which are in between the decimal values, the fractional values, they are also applicable. So here there is a convention. Here the solution is the relationship x is lesser than or equal to 5. So 5 is also part of the solution. So all the numbers starting from 5 and to the left of it, because it is lesser than 5 included, they are part of the solution. So we'll highlight them with a solid line, okay, like this. Please forgive my drawing skills. So on the number line we'll draw a solid line starting from 5, highlighting 5 with a darkened circle. Why? Because 5 is also part of the solution, okay, and all these points which are there in between these, integers, they are also the decimal values, the fractional values, they are also part of the solution. And it goes like this because it is real numbers which are talking about, the replacement set. It is the set of real numbers. Now suppose the situation would have been that x is lesser than 5. The equal to sign, the lesser than or equal to sign is not there, only lesser than 5. In this case, here 5 is part of the solution, it is included. But in this case, 5 is not part of the solution. So in this case, what we'll do, as there are infinite number of points in between any two given values, here we will highlight 5 with a hollow circle. A hollow circle to indicate that this is not included in the solution. And we'll again draw a solid line to indicate that all the values, all the points which are lesser than 5, they are part of the solution. But 5 itself is not part of the solution. That is highlighted by this hollow circle. That is the convention. When the circle is darkened, then it is part of the solution. When it is hollow, it is not part of the solution. Same case can be done for, let's say, we have, instead of x lesser than 5 would have been x greater than 5. Then would have done it in the other direction. Starting from here, all the numbers to the right hand side of 5, they are part of the solution. Similarly here, greater than equal to 5, we would have included 5 with a darkened circle and drawn a line, solid line to the right side, going to the right side. So everything greater than that and including 5, they are part of the solution. Okay, so this is for x greater than equal to 5. The line goes to the right hand side. Here it is for the green one is x greater than 5. 5 is not included, and everything else which is to the right of it, greater than that, it is part of the solution. So this is the convention, always remember that. And we'll be discussing a lot of questions, and a lot of tricky examples will also come, tricky things. So we'll be discussing it in the numerical problem section. Okay, so this is the basic